Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why? Or sent out frustrating Slack messages trying to find the right dataset? Or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all of this collaboration chaos firsthand, and they started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Justin Mejorada-Pier and Charlie Gu about Querybook, an open source IDE for your big data projects. So Justin, can you start by introducing yourself?
Sure, Tobias. So I'm Justin, the engineering manager for the Linux platform team at Pinterest. I've been at Pinterest for 6.5 years now. Most of this time working in data, building internal data tools for the rest of Pinterest employees. And we have several tools like this, and one of them is Querybook that we're talking about today. That's mostly it.
And Charlie, how about yourself?
Hi, I'm Charlie. I have been at Pinterest for 4 years now, and after I graduated from University of Waterloo, I have stayed on the analytics platform team for the past 4 years and mostly focused on building internal data tools for Pinterest employees.
And going back to you, Justin, do you remember how you first got involved in data management?
I moved to the data team shortly after joining Pinterest. I did some Q&A demos that were relevant to the team. In the data team, there was several areas that we basically supported our end customers with. For example, in A/B management, like lifecycle management, like for our A/B experiments, or charting and dashboarding tools. And then one of these areas was data management. So the first time that I worked on that as a product was with Querybook. So maybe I can talk more about it once we talk about how Querybook got started. That was mostly it. It was one of the charters of our team.
And Charlie, how did you first get involved in data management?
So after I joined the team, I was working mostly on the experimentation and the dashboarding features for our internal tools. And then Justin mentioned about this opportunity to build this querying tool, which is now like Querybook. And then that's how I got started.
And so in terms of the actual project itself, can you give a bit of an overview about what it is that you've built with Querybook and some of the story behind what motivated you to create this tool internally versus picking something up off the shelf?
So we started Querybook around 2017. At that point in time, it started as an intern project. So we had an external vendor solution. However, it had some things that we would like to have it done differently, or that we wanted to improve, or that we wanted to connect better with Pinterest ecosystem. So just as an exploration project, we asked basically our intern and our team to try to build like data cataloging, a small application to be able to better integrate with our systems at Pinterest. At the end of the internship, we also are basically the intern, in this case, Lauren. So she was able to finish first version of this data cataloging feature, but also querying or data querying functionalities to it. So it ended up being faster than what we expected. That gave us a bit pause to, hey, maybe we should explore this area a bit more. Charlie joined this project. he rebuilt most of the architecture so that, because now it was no longer like MVP, but rather more like full-blown exploration. We started thinking of like, hey, should we continue down this path? Should we keep using the solution that we're currently using from the external vendor? Or should we go with an open source solution? So at that point in time, we explored several solutions that were back in the day. Superset, I think at that point in time, called Caravelle, along with other options, both open source and commercial. We found very good ones, but we did not find exactly what we were looking for. So, for example, we found there were several data cataloging solutions which handle like the metadata of the tables and all of that. And we found several charting and dashboarding solutions, or slicing and dicing, like Superset. And all of them were very good in what they do. However, we did not find a solution that combined both things, basically that combined data cataloging with data querying and dashboarding. And also not a solution that allowed for easy narratives to be created around data, which was our main focus of what we wanted to enable. Basically, we wanted to enable people to be able to ask a question like, hey, why is this incident happening? Or why is, for example, the number of users going up or down on this given country? Run an analysis easily without having to know Python to run it. For example, if they were using Jupyter, document this and easily share with other people. That's why we went with the narrative or kind of like notebook-like UI. So based on this initial evaluation, we thought it was worth exploring more, basically giving us 6 months more to build a more fleshed out prototype. And then based on the initial customer response, of course, there was a lot of rough edges back then, but we decided to actually pursue further. User response was that they preferred it much more than the other alternative. Then we just like replaced our existing solution with the new one. From that point, it was mostly just taking user feedback and iterating a lot, fixing a lot of things, a lot of rough edges, and just trying to make the product a bit better over time.
And in terms of the main use cases that you're using it for and the sort of motivation for going with this notebook style interface versus the kind of traditional business intelligence dashboard, I'm wondering if you can just talk through some of the kind of overlap between Querybook and some of the adjacent types of tooling that are available. So you mentioned Superset, but also, because it's notebook style interface, it brings to mind things like Jupyter and just the use cases that Querybook is uniquely well suited for and sort of where it fits in the overall ecosystem and use cases at Pinterest.
The main gap that we want to focus on is being able to allow engineers, data analysts, product scientists, and even PMs to be able to quickly answer the questions that they may have through data and then share this. Basically, what that means is normally in many of these other tools, queries are handled like as independent entities or even a group in a folder, just like the place where you write a SQL query or like a Hive, Presto, and so on query. You get results and that's it. And then people go on into Google Docs and then create the narrative around those, and then they link to many of these different queries and entities or charts or dashboards. However, this is like a tedious process because you have to then copy paste a lot or provide links here and there, basically jump through different applications. So what we wanted to enable is to kind of like decrease the friction. You don't have to now basically, most people just end the analysis in the Querybook, just with adding a couple paragraphs here and there of explanation, and then sharing it very easily with their teammates. Even collaborating with real-time collaboration now directly on the Datadog, which is like a very different experience from many other tools that may exist right now. Basically, we want to enable like fast analysis for people, and then they can just like share it and that's it, and they can move on to their daily work or their other things that they may have to be doing. If they want more in-depth slicing and dicing of the data, maybe using Python, and they also happen to know Python and they also happen to know pandas and like all of the data science toolkit, then they can definitely click on like say export to Jupyter, because we also have like a Jupyter installation of Pinterest where they can follow up on that process, and then they can just like do the real like heavy duty analysis through Python if they prefer it to do over directly on Hive or directly on Presto. And that's something that people do definitely, but we want to enable that, hey, if you can just answer your question directly on Querybook, then it's like you should just go ahead and not have to spend that much amount of time on the other things. So that's kind of like how it interacts with our other tools that we have or that exist out there.
And when you do export it to Jupyter, I'm curious what's actually contained in that export. Is it just a link to the sort of rendered data sets so that you can import those into the Jupyter notebook, or sort of what the interchange format looks like? And if there's the possibility of sort of going back and forth between Jupyter and Querybook, where maybe you go to Jupyter, do some additional analysis, and then export a new data set that you then bring back into the original data doc.
Sure. So basically, like how it currently works is that you export. So once you click on export, it will open the Jupyter kind of like internal application website, which will have a new notebook with your query in it. So that it's ready for you to just press and like run in the Python Jupyter format, for example. Then you can just like put it into a data frame, the normal traditional Jupyter slicing and dicing of the data. Once you're done with that, if you wanted to, let's say if you wanted to continue then on Querybook, you could then save it as a new table. And then once it's saved into the new table, you can then use it again on Querybook if you wanted to.
And in the tagline for Querybook, it calls out the fact that it's an IDE for big data, and big data sort of as a term is something that gets thrown around a lot with different meanings and different intentions behind it. And I'm wondering if you can just talk through sort of what you're trying to aim for with that tagline and some of the ways that that focus manifests in the ways that Querybook is designed and the feature sets that it has and the overall user experience that it provides.
Let's compare the big data IDE, which is Querybook, to like a small data IDE, which is something like a SQL Pro for MySQL. So what are the differences? Normally, like a MySQL database has a lot less tables. So for example, a MySQL database may only contain like hundreds of tables. And whereas for Querybook, like currently at Pinterest, we handle tables at like size of like tens of thousands, like maybe close to like 250,000 tables. So that's like one thing we have to optimize. So what we did is that we actually pushed our tables information and search index onto Elasticsearch to provide also suggestions. So that's one of the like design choice we made to support this kind of larger scale. Another thing we had to focus on is that the query results and the query runtime for big data are much longer and larger. So for example, like a typical MySQL query would time out after 10 seconds. Whereas a Querybook query can run for like days, maybe for like close to a week. So to make sure that will work, we have to like create async workers to make sure the query can like run much longer. And then they have to also send out progress updates or logs back to the user. So then they can know like how the query is running currently. So that's also another optimization Querybook has to focus on. Another thing is the query results. So a MySQL table is typically like gigabytes in size, whereas Querybook tables can be in size of like terabytes or even larger. So a typical query results for MySQL is very likely to be much smaller. It could be like sizing of megabytes, but like users on Querybook would query like gigabytes of data. So what we did is at Pinterest internally, we will upload the query results to S3 and then format it in CSV such that we can like only read chunks of it to the user. And if they want to see the full result, they can download the data directly from S3.
And I'm curious about your choice of CSV as the interchange format and why you didn't go with something like Parquet or ORC for being able to chunk the data and use it more easily for other downstream analysis that would then preserve some of the type information and schema data.
Oh, it's more like a design choice very early in the tool that we didn't really bother to change. I think we chose CSV just because like when people want to download the data, it's very easy for them to read it on their laptop. They can like put it into Google Sheets very easily. The advantage of that is that like for the CSV format, we can also like being able to read it line by line and then just read a certain chunk of it. So for example, on Querybook, we set a max limit of 5 megabytes for the previews. So then we don't show any more data that would like lag the front end website. I think like moving forward, we could think of like changing the format of CSV into another format, but like right now it's more like an early design decision.
Yeah, it's definitely useful context to have because it's always interesting to look at what are the design constraints and limitations that you're working around and the things that you're trying to optimize for as you're building out these different tools. And I could definitely understand the desire to optimize for ease of use as you're downloading it on your laptop for being able to shorten that iteration cycle versus, okay, I've got a Parquet file. Now I need to break out another set of tools to be able to understand what's even in here.
Yeah, that's totally true. When we started I don't think our company enforced Parquet. It was something that we started to do in 2018. So we also made into our decision to use CSV.
In terms of the actual target users of the Querybook platform, so you talked about it's kind of aimed at these different roles within the company. And I'm wondering if you can just talk through how the kind of personas that you're building around has influenced the feature set of Querybook and the primary capabilities and the interaction patterns that you've built into it, and how that plays into how you think about the overall role of the tool within the company.
So when we were designing Querybook, we did talk with a lot of users. We tried to see how they were using the existing product or the existing solution that we had for them in the company. We found that like a lot of users were not necessarily using it as intended. And then they actually had like, for example, their queries stored in their local file system, even though there was like a feature to store queries in the product itself. And many people even use like notepads or like Evernote, those kind of things in order to store their queries, to provide like context and like a bit more information on them. So that definitely helped guide, or kind of like that informed a lot the design decision of why we went with like a notebook kind of interface. Even of course, like it is like very, very similar to like, I mean, like how Jupyter would have like a notebook interface. Our main inspiration was more like the people were using like things like the Mac OS Node applications in order to store their queries. So we wanted to replicate what they were already doing. So that is an example of how users definitely help guide the direction or the design decisions on the product. As that example, there has been many, many cases, because to go back to your question, like our users are kind of like data scientists, product analysts, engineers, and product managers. So it's a very big combination of functions, and they all have very different needs. The needs of a data scientist compared to like a product manager are very different. So we try to provide as much as possible what each function requires, however, without complicating the product, because one of our main things is that we don't want it to feel like a technical product or like something that you require like to know a lot in order to properly use it. I mean, of course, we have some advanced features, but those are more hidden away. So like the more casual users are not like intimidated by them. In terms of like the general direction, so we're mostly clear in the sense like we wanted to function like it's just to be the first step where people start their analysis before jumping to, if necessary, to Jupyter for the subset, maybe the 20% of the advanced analysis they want to do. And maybe before jumping to our other internal solution for dashboarding and charting. So we do have like, kind of like, because we started like in 2014, so we do have like an internal solution like Superset that is meant for interactive slicing and dicing and charting and dashboarding. It has different characteristics than Superset. I mean, I think Superset is a very great solution for that. But then the idea would be, again, like people start on analysis first on Querybook, and then if they need to do charting and dashboarding for slicing and dicing and presenting this on a kind of like weekly cadence for a meeting, they can do that like directly on our equivalent of Superset. If they want to do like in-depth slicing and dicing with Python, they can do that with Jupyter. Therefore, basically, we have focused on this core need, which is like in common between all three functions, between of like engineers, PMs, and data scientists.
And in terms of the actual implementation of Querybook, can you talk through the overall architecture of how it runs and some of the specific design choices that you made to be able to handle the scale and sort of the big data focus of it?
Our front end, the web server that like hosts web pages and APIs, that's through Flask. And we use the UWSGI for scaling. It talks to a Celery worker via a Redis connection. So we also run a set of Celery workers, and those Celery workers would handle running the actual queries and then pulling the results from these query engines and then uploading them. Other than that, the front-end Flask server also can push updates like such as like the query running logs, like query status updates, or like if you're doing collaborative editing. It will also push like live updates such as like collaborative updates through a WebSocket connection to the front end. So that's via Socket.io. This also goes through another Redis connection. Other than that, the worker would connect to AWS 3 to like push the query results there. And then it will also connect to Elasticsearch. So like, for example, if you edit a Datadog, then the Flask front-end server would push an async job through Redis to the Celery worker to update the Elasticsearch search index so that when people search for the Datadog, they will find it in the Elasticsearch. Lastly, there's a scheduler. So the scheduler's job is for people to run like a scheduled Datadog, or there are some scheduled jobs in Querybook that can be used to index like metastore information, like the table and database information, or it can be used to like clean up like older query results.
And then in terms of the actual design of the system, I'm curious how it has changed or evolved since you first began working on it, and some of the assumptions that you made early on that you had to update or work around as you began introducing it to more of the company and it began to be used more and you saw sort of the specific usage patterns that people were employing.
So in terms of the product, how it evolved is that we focus first on the just having kind of like an interface for the data, the big data at Pinterest, basically like a data cataloging problem space, something similar to, say, LinkedIn's Data Hub or Lyft's Amundsen or many other external vendors. So that is where it started. But then we evolved our thinking into supporting the collocation of the querying interface in the same product. And that's when we added the querying capabilities into it. Lastly, the final kind of like main part that we added is the ability to chart on dashboard quickly. I mean, it's not meant to be like a full-blown, again, solution like Superset. It's meant to be just like the starting point. So similar to having Google Docs, you can add maybe Google Drawings or you can add like tables. But if you want to have the full-blown solution for that, you can go to basically the Google Apps drawing application, or you can go to Google Sheets. It's a similar organization that we're aiming for with Datadogs and Querybook. And in terms of the technical aspects, Charlie, if you want to talk about if there is anything interesting that you found in the evolution of it.
I think the biggest change is the collaborative editing. So when we first designed this tool, we did not think about collaboration at all. It was basically one user and then one Datadog, and then we just treat it kind of like a local file. After we started to have everyone in the company to have access to Querybook, they were starting to ask can I edit someone else's Datadog? Can I share this with someone else so that can I give it off to someone else? So we really have to think about collaborative editing. This is when we kind of have to re-architecture a lot of the code so that it kind of pushes changes through WebSockets to other people who are also viewing this Datadog. So that's one of the more technical change here. And another thing that was changed was we added scheduling. So before we were thinking that Airflow, which is used internally at Pinterest, would be good enough for people's scheduling needs. But then it turns out to be a very common requirement for people to run some queries and then export it to Google Sheets and then to view it. And then they find that the whole workflow of creating some Airflow jobs is a lot of burdens. So we actually added scheduling feature, and then you can actually create a Datadog schedule in matter of minutes, and then you can auto export data to the same Google Sheets every day.
Because of the fact that Querybook does have this scheduling capability and you also have Airflow for running your pipelines, I'm curious how that factors into any sort of data lineage tracking or sort of metadata flows that you have within Pinterest for being able to track execution or tables that are created using Querybook as compared to other workflows that you might have where you might use Airflow or maybe dbt for building different data views, and just how you keep track of the work that's going on where.
So that's actually something the data team at Pinterest is working on right now, is to come up with a data lineage that's for every data team at Pinterest. It doesn't really matter if the query is executed from Airflow or it's executed from Querybook. They all go into the same engine, and then the engine will log those queries and then push them back into Hive for analysis. So it will just come from different sources, but all the queries will be recorded in the same table.
And then another thing that's worth digging into is the data cataloging aspects of Querybook, where you mentioned that one of the original purposes of the project was to be able to build out this catalog to understand what tables you have access to and maybe see how they're being used and track that. And I'm curious if you can talk through some of the capabilities that Querybook has and the way it's being used for a cataloging perspective, and maybe how it compares to other things that have come out in the ecosystem since you first began working on it, such as Amundsen or Apache Atlas.
As you mentioned, like when we first started working on this, there was not a lot of like, or at least not a proliferation of like data cataloging solutions in the open source world, which is great to have. So I think that as far as I know, Amundsen was not there, and then like LinkedIn's Data Hub was not there, among other things. So right now it's a bit very similar to some of these other products. I would say most of the features, like the intersection is very big in terms of the features that are available in each platform. In our case, what we currently have is basic things like the table information, like table description, details, table metadata, information on the high metastore, column description, the ability to add comments to the column, of course, type information, data lineage information. So we support ingestion of this data through an API, but we also generate part of this data from the queries that get run on Querybook itself. We also support showing the source query for a given table, who is using and who is the top users of a given table, example queries of such table, basically the queries that have been run on Querybook. We just group them over and show them in the UI. Warnings and alerts. So for example, if a given table is like having a downstream issue or upstream issue and the data is incorrect, we can just flag them. And then the nice thing is that, for example, in your editor or in the Datadog view, you would get those warnings, or everyone would get those warnings, so that they don't use a table if it's maybe bad for that day. Those are the main features that we have focused on so far in Querybook. The main differentiator would be that instead of having to go into different UI or different system or a standalone UI, like then see all of this information and that's it, by integrating it into the overloaded term. But the reason is because if you have this collocated with your querying interface, then you're able to do like very powerful stuff or interesting stuff like auto-completion, warnings, all of these things that would be maybe not there if it was a different product.
The difference between Querybook and all other analytics tools out there is that most of the ad hoc query people run at Pinterest will run on Querybook. So we have a lot of data internally for analysis. And then we can use those analysis to power auto suggestion. Like, for example, people query this table more commonly, then we know that this table is popular. So then we can actually boost it up in the search index itself. We can also use information for example, we can use people's query information to auto create lineages, so then we know which table comes from another. And so there's a lot of potential there for auto query analysis in Querybook.
Patrick is a diligent data engineer, probably the best in his team. Yesterday, when trying to optimize the performance of a query running over 20 billion rows, he was so eager to succeed that he read the entire database documentation. He changed the syntax, he changed the schema, he gave it his everything and reduced the response time from 20 minutes down to 5. Today is not a good day. Sarah from Business Intelligence says 5 minutes is way too long. John, the CFO, is constantly slacking every living being trying to figure out what caused the business intelligence expenses to grow so high yesterday. Want to become the liberator of data? Firebolt's cloud data warehouse can run complex queries over terabytes and petabytes of data in sub-seconds with minimum resources. No more waiting, no more huge expenses, and your hard work finally pays off. Firebolt is the fastest cloud data warehouse. Visit dataengineeringpodcast.com/firebolt today to get started. And the first 25 visitors will receive a free Firebolt t-shirt. And in terms of the actual workflow of getting started with building a data doc in Querybook and sort of discovering the data assets and working with it, and then you mentioned the collaboration capabilities, just sort of the overall workflow of saying, I have this question that I'm trying to answer. I'm going to go use Querybook to be able to answer it, and then just the sort of end-to-end flow of question to solution, and then sort of the life cycle of the data doc after I've come to a particular conclusion from the question that I've asked.
Sure. I mean, the overall workflow is very small. It doesn't have a lot of steps. You can go into the website, the UI for it. Then you can click on create new data doc. Once you have your data doc, you can just start typing. That will be your first query. If you already know the table that you are going to use, maybe because it's like a table that maybe your team, or basically a problem space that your team often works on, and therefore maybe there's like a few, like say 5 or 10 tables that your team often uses. So then you can just start typing, it will get auto completed. If you want to have like a reminder, for example, of which columns or the schema of it, you can just double click it and then you will get the information of it in a sidebar. So similar to the experience of like using like a real IDE for like programming. And then you continue writing your query. You run it once, you get results. You can modify your query because maybe you do like another dimension of it or another flavor of it. Then you run it again. You get like the historical results if you want to go back to them. Maybe you are satisfied with that first query. You then create a new query in the bottom below. Then you add your second query. You maybe now slice and dice it for a different aspect. For example, maybe you first slice it by the country, you then slice it by the gender to see if it's a different behavior among different population. You may slice it in a third query by a different category, maybe language. Then once you find the reason or the answer to your question, you can add new cells between those query cells, maybe like text cells. You can explain the rationale of like, hey, in this first query, we are slicing by country, but actually we did not find like anything meaningful in the behavior basically of this drop in usage, for example. Maybe you add a little bit more clarification in second and third query, and then you can add like kind of like a final thought. But once we slice it by language, we found that Korean users dropped dramatically, and we then checked with the team, and it is actually because it had a bug in the translation layer, for example. Then once that's done, you can of course give it a title to your data if you want to, and then you can just click on share, just like a Google Doc. You'll get a very similar model like any modern application, and then you can specify where you want to keep your data doc as private or where you want to make it public. And if it's public, everyone will see it in the company. And if it's private, you can invite like some collaborators to it. Yeah, and you can give them either view or edit access. If you edit access, then they'll be able to collaboratively edit, as Charlie mentions. And if you have view access, they'll just like be able to see it. That's mostly the end of the workflow. And then if you did not exactly knew which tables to use, you could also start your journey like in the sidebar of like searching for tables where you can kind of like type something in. For example, maybe pinners or engagement or click-throughs. And then you'll find related tables to that. If you click on them, you'll find more information on each of them in order to be able to more easily narrow down your search to the right tables. It's something that we want to improve on. Basically, right now, you can find tables that you're looking for using Querybook, but it's something that there is still a lot of opportunity area in order to find the right table like as fast as possible. So it's something that we want to double down on.
As we've been discussing, this is a tool that started off internally with Pinterest because you were trying to solve your own needs. And, since then, there's been a proliferation of tools that are in adjacent spaces to what you're building with Querybook. I'm wondering if you can just talk through your reasoning and motivations for open sourcing the project and the technical aspects and organizational aspects that you had to unwind in the process of making this an open source tool.
So in terms of the rationale for it, there are several reasons. Just like any company, we would like to be able to contribute to the open source community in order to, Pinterest as any other company uses a lot of open source tools. And if we can contribute back to the community, that would be a great outcome. Second thing would be, of course, being able to benefit from the input of this community in terms of the direction of the product. That will in turn help make the product better at Pinterest because it will end up being a better product. Lastly, of course, we would love it if the community as well is able to contribute to the product, maybe both features or integrations or even bug fixes. That would be super beneficial to the internal usage of it at Pinterest. So these three main driving factors led us to decide to pursue this route. And because also, of course, we did an exploration of like what was available in open source at the point, we didn't see like a clear, there were products that were doing parts of what Querybook does, like a lot of products that do data cataloging with querying capabilities. A lot of products do that full-blown slicing and dicing with sharding and dashboarding. And then like full-blown Python analysis, heavy duty with Jupyter. But we didn't see like exactly the intersection, exactly what we were aiming for with Querybook. So that led us to think of like that it was something useful to open source. That's mostly it from the rational perspective. Charlie, do you want to talk more about basically the changes that were needed to be done in terms of making it like technically possible to open source?
So there are a few areas we had to change. One is that we hard coded a lot of things because we assume there's only like several query engines we use, and then they all use the same meta store. That's no longer the case with the open source version of Querybook, where you can add like arbitrary query engines, and then you can add like associate them with arbitrary like metastore like database information. So that's like a one very large architecture change we have to do. Another like areas of hard coding is that we often get requests such as, hey, if you run Presto query, or if you run this query, then show this message to the user. Or if you want to schedule a query that has like a Presto, if you want to schedule a Datadog that has a Presto or certain query in it, show this warning. So we have a lot of like internal requests such as those, and they become much harder to do with open source because we can't like put something so specific in there. And then that's like one area we really had to change. And then so what we did is that we took out all the internal Pinterest code and then put them through the plugin system so that they can be used internally, but then they won't be exposed for the open source code. Last change we had to do is to make the setup life easier. So before the installations instruction for Querybook internally was like everywhere. There are like 10 steps. Like you have to install this library, then you have to like do this, do that, and then you can start the Querybook process, and then you have to start the worker on a separate process, and then you have to do this all manually. But then we figured that will be really complicated if we open source this thing. So what we did is that we make sure there's only one Docker command that can start the whole thing. So you can just run make in Querybook and we'll start a higher demo service. We added a demo setup, so it would auto inject all the like the demo data, so then you have something to try out when you just clone it from GitHub. We also added admin tools, so then you can try it out very easily.
In terms of the extension points that you've had to build in the process of open sourcing it, I'm wondering if you can just talk through the opportunities that opens up and just the available interfaces that you've built into Querybook for people to be able to customize it to fit their own needs.
So when we built the plugin system, I kind of took the Airflow plugin system as a reference because I saw that the Airflow supports a lot of different customizations. So when we built the plugin system, we also wanted something similar. Right now, it's not the perfect model. We want it so that people can actually share their plugins in the future. So then you can add like different functionality into Querybook without like putting too much code into the main repo. And in terms of plugins, so we support custom authentication. By default, we kind of provide like Okta and Google and Google OAuth and then LDAP OAuth. But then I think different companies have like different authentication system, and then they want to fetch different information from different sources. So that's why we have a custom authentication plugin. And another plugin we have is for like query engine and Metastore. So this is a very heavily used one internally at Pinterest. So we want it so that like we can fetch like analysis from like different sources while you're running the query. So for example, internally, if you run a query, we can actually show you your current like memory usage information directly on Querybook. And that's something like that's not included in the open source version. Other than that, there's also plugins for like exporting. So internally, this is used to export to different internal tools that can actually further enhance the query results. We also have like front-end plugins. So there's a front-end plugin called Result Transform. So what this does is that when you query in Querybooks, for example, at Pinterest, we have a lot of like pins, right? So when you query something that has a column pin ID or image signature, it can translate that pin ID into a link. So then you can just click on that pin ID and it will redirect you to the pin at Pinterest. For image signature, we can actually find out which image it is by reverse mapping it. So then you can actually just view the image directly inside Querybook. So those are the different functionalities of plugins.
And in terms of the lifecycle management of the query results, I'm also curious about that, where you mentioned that a lot of them get exported to S3. And I'm curious how you manage to avoid too much sort of propagation and data duplication in the stored results, and what your thoughts are on expiry of results as a data doc ages out, or as sort of the query gets executed in different locations, and just the overall thought of reducing the amount of extra data that you have to keep around for the purposes of the data docs versus the amount of time it takes to regenerate that data set after it's been created.
Well, there are several things. Right now, the data on Querybook, at least internally, does not last forever. So we have a 180-day expiration policy. So any data on S3 will be deleted after 180 days. And then internally, we also have a cleanup job that kind of removes all the queries after 365 days. So that query will be deleted permanently forever. We do want to have an additional feature that can let user mark some of their query results so then they can keep it for longer. In terms of just clean up data on S3, to make sure there's no duplicated data, we actually have a working group right now to kind of detect S3 access to those data, and then also checking the Hive Metastore access for the tables, and then we'll remove those tables or data if there's no access.
In terms of the ways that Querybook is being used, or your own experience of working with it for building different data docs and analyses, I'm curious what you've seen as some of the most interesting or innovative or unexpected ways that it's been employed either inside Pinterest or elsewhere since you've open sourced it.
I can give 2 examples. So one is that while we're doing the open source, we added MySQL functionality, just so then we can see what kind of engines can actually be supported on Querybook. And then I actually connected the MySQL database that's used by a lot of internal tools for our team. And then some of our teammates actually start to use Querybook for MySQL because they figure out that you can share your queries very easily with other people. Also, you can save your alter queries, save your create queries, so then you can always go back and see what you have done. So to my surprise, we actually start to use Querybook more for MySQL querying for our internal tools compared to traditional tools like SQL Pro. In terms of externally, so I think Grand Rounds was one of the early adopters of Querybook, and they have added a lot more interesting features around creating tables. So what they added was that after you run a query, you can actually create a view or a table on top of this query result, and then it goes through they added a lot more UIs for the table creation, and then it actually has I think it's a GitHub integration that kind of lets you kind of view your changes on GitHub directly afterwards.
And in terms of your own experience of building the Querybook platform and sharing it within Pinterest and then releasing it as open source and working with the community as it starts to gain adoption, I'm curious, what have been some of the most interesting or unexpected or challenging lessons that you've each learned in the process?
I think the biggest learning for me was the importance of talking to our users, basically having a very, very tight feedback loop. So we interact with them, and basically Charlie and Lina, who are the 2 engineers working on it, they also interact directly with our users. So we don't have intermediary. So this has helped us iterate very fast and get a feeling of what users like and what they don't like over time. And we have, learned a lot and fixed our own mistakes over time. The biggest learning in terms of the importance of it compared to some of our other products that we may not have been that directly involved with our users. And I think that has been what has allowed Querybook to grow very fast within Pinterest in terms of user adoption and in terms of user satisfaction. That has been the biggest learning for me.
I also have 2 to share. One is that when we interact with users, I notice that they will often give out very specific instructions on how it will solve their pain points, such as oh, you can add a button here, or you can add this feature here. But we shouldn't really do exactly what they're told, but we should think about what their pain points are. It's actually much more useful to gather a lot of users' pain points and then come up with our own design for it. So then it can actually solve a larger problem and then not make the product go into a direction of a specific user. Another lesson I learned is kind of the law of diminishing returns. We actually wanted to add a lot of granular features into Querybook. So for example, I kind of want to add a full Presto parser that will give users exact syntax errors as they're typing out the query. Also kind of wanted to work out a much better collaborative editing system for Querybook that can like do it kind of like what Google Doc does. Because like right now, Querybook's limitation is that two users cannot edit in the same cell or else they will overwrite each other's queries. But then I noticed that these two features I mentioned, they're really great to add, but then they will actually cost a lot of work. And then the benefit of having them to users are pretty low compared to the amount of work we have to do. Whereas we can dedicate this time for other features that can actually greatly help users' productivity.
For people who are looking to be able to do collaborative analysis, or they want to be able to build a sort of notebook style workflow for integrating queries and prose, I'm wondering what you've seen as the cases where a Querybook might be the wrong choice and somebody might be better served with some of the adjacent tools in the space.
Some examples where people, they will be better served by our tools is if they have a specific thing in mind that they want to create. Something specific as, for example, I want to create a dashboard that I can use on a bi-weekly basis or on a daily basis with my team on a given team meeting. And I want to be able to slice and dice interactively those results. Then they would be better served probably to use a superset for that or any other like interactive dashboarding solutions. Because Querybook currently, it's meant for non-interactive use in sense like even though you can have like fast engines like Presto or Spark SQL or similar, the interface and the user mode is like different. So it's not necessarily meant for dashboarding. So that would be one example where you would rather prefer to start in another product. Another example, of course, is if you want to build an analysis and you know that you prefer to use like Python to slice and dice your data and that your data set actually is able to fit in memory in your Python, basically in your Jupyter instance, in your kernel. Then, like, I mean, of course, you can just start in Jupyter itself. I mean, some people, like, what they do is, like, they create their queries in Querybook because they have, like, all the metadata enrichment capabilities there. So they draft their queries in Querybook and then they can, like, move on to Jupyter to do the Python analysis. But still, I mean, there may be cases where you want to start either in a Jupyter notebook or a similar solution. Another situation where it could be better for you to start in another tool is like in workflows. In the sense like, even though Querybook allows for and provides simple scheduling, quick and simple scheduling, it's meant to be like ad hoc. So if in case you want to run a Datadog quickly, like on a daily basis and get some results in an email or in a spreadsheet, something basic for people to use. But of course, if you want to like a full-blown scheduling, you should definitely use something like Airflow or any similar. That would be the main examples, I would say, where you probably want to use a different solution like that.
And in terms of the future work for Querybook, I'm curious what you have planned for the near to medium term or any use cases or capabilities that you're excited to add or enable.
Our current like most focused one is to add more like integrations for open source. There has been a lot of asks to support like BigQuery or adding more like data catalog features for different query engines, adding like more query engines, or adding like Terraform and Helm charts for continuous deployment. So these things are on top of our mind right now. So then more users can actually start using Querybook. And in terms of near future, we're working on expanding the feature of the list feature, which is a way to organize your data docs and tables into like list and share with others. So that's something we want to work on in the near future. And then another thing we're excited to work on is the table creation feature in Querybook. So as to close the loop, right now, like you can do like insert, update, and delete in Querybook. But then if you want to create a table, you can't really put the data into Querybook and let it like create a table for you. And then that's something we want to work on.
Are there any other aspects of the Querybook project or the overall space of data discovery and data cataloging and querying and notebook interfaces or sort of the use cases that you're targeting with Querybook that we didn't discuss yet that you'd like to cover before we close out the show?
Some of the areas that I find very interesting and like I haven't seen like a very good solution either with, I mean, what we currently have with Querybook or with other external vendors or open source projects. I mean, finding the right table for people to use. Even though, I mean, we have, of course, many features towards this, and there's many other projects like Amundsen and so on that try to tackle the same problem. I think that it's still not as efficient for people as it could be. So it's something that I expect to see a lot of improvements over the next years. That's kind of like an area that I'm excited about. How about you, Charlie?
Yeah, actually, I get a lot of questions daily from like, how do I find this table? How do I find that table? And then it's kind of more like a tribal knowledge right now. It's very hard for people to find the table they want for like the specific data.
Yeah, it's definitely one of the perennial challenges, and everybody solves it differently. All right. Well, for anybody who wants to get in touch with either or both of you and follow along with the work that you're doing or contribute to Querybook, I'll have you each add your preferred contact information to the show notes. And as a final question, I would like to get each of your perspectives on what you see as being the biggest gap in the tooling or technology that's available for data management today.
This is probably like similar to my previous answer, but I would say in the immediate space, it would be finding the right table for people to use. Basically, there is so many duplicated tables, so many wasted time by engineers and by everyone in the company trying to find the right information. And there's a lot of like approaches and there's a lot of attempts at this. I mean, including, of course, things that we do at Querybook, but things that our products do, like Amundsen or Data Hubs, LinkedIn, and so on. But I mean, I would expect this to be very different 3 years, 4 years from now, once better solutions or improvements to these products happen. So I think that would save a lot of time for engineers, data scientists, and any employee at the company. So it's something that I'm excited about, definitely.
Other than data discovery, I think another thing is like right now we kind of have support like for Spark SQL, which can run for like much larger data, and also Presto, which is fast, but like since it runs in memory, it will only work for like a small amount of analysis. So I would like to see like kind of like query language can actually balance the two where it's like fast for smaller queries, but then it doesn't have the memory issue of Presto.
All right. Well, thank you both for taking the time today to join me and sharing the work that you're doing on Querybook. It's definitely a very interesting project and one that fits an interesting Venn diagram in the space that I have not seen filled before. So definitely plan to experiment with it myself and keep a close eye on it as it progresses. So I appreciate all the time and energy you've put into building it and releasing it to the community. So thank you for that. And thank you for taking the time. And I hope you enjoy the rest of your day.
Thank you so much.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.